So just a few updates before I go ahead and get started. The midterm, the information about the midterm. So after this class, I'm going to go ahead and send out an email about the steps for signing up for the midterm remotely. So if you want to take the midterm remotely, I'm just going to send out the steps for how to do so. And this will be, when you take the midterm, will depend on which group you're in, either group A or group B, but you will take it at 9:30. You take it in person. I think in person, we got moved to another room in Fayard Hall. So I'm going to explain all this in the email, but mainly I'm going to send out information regarding how to sign up for the midterm remotely and all that other information. So it should be pretty straightforward. So expect that email afterwards. Additionally, so the next homework, so we're going to be finishing equations of the quadratic type today. That homework, I have that due tomorrow. So make sure you are aware of that. And of course, the midterm is next week. So the practice for the midterm is already in my math lab. So you can start practicing on that whenever you feel, well, primarily once you complete everything before it. You can start practicing for the midterm. Other than that, I think that is it. Again, I'll send out an email after class and I'll update everyone on the midterm, everything that needs to be known in regards to it. So let's see, recording. Everything looks good. All right, let's go ahead and start. So last time in class, we were talking about equations of the quadratic type, and we did the first two examples here. So just as a refresher, that what this comes down to is forms that look quadratic. They are of the quadratic form, but we can't necessarily apply quadratic steps to them because they are not, in fact, quadratic. So what we have to do is replace this pattern with a U, or rather a U substitution, and this substitution will give us a quadratic, and then we can proceed with quadratic methods, such as factorization primarily. So we did the first two already, so we're going to jump down to problem 3 here. So problem 3 here, it's some form that it looks quadratic in nature because there's something squared minus 12 something plus 36 is equal to 0. So that's pretty much the quadratic feel of it. It has the quadratic form, but it's not a quadratic. And so we can't simply just change it without making some sort of rule. And this rule, as I mentioned in the last class, normally the middle expression, the middle variable expression gives us a good idea as to what U shall be. And that makes sense as a choice of U, because if you square that, then U squared is right over here, and it extends very nicely. So if anything, now we can take this expression and rewrite it as U squared minus 12U plus 36 is equal to 0. So that was the goal. So now we have rewritten the equation of quadratic form into an actual quadratic by using what we call a dummy variable. And from here, well, this part moving forward isn't too bad because now that we have a quadratic, we can go ahead and factor it as such. Seems to be 6 and U minus 6. So two numbers that multiply together to give us a positive 36, -6 and -6, and they add together to give us -12. So from here, it's really just a matter of solving for u minus 6 is equal to 0. We get this twice, so we only have to solve it once. So u is 6. Yes.
So that's the completed answer?
So this isn't the final answer.
Okay.
Yeah, we have one more step. So even though we just did a sequence of steps, I see this happen a lot of times when I teach this class. People will conclude with u is equal to 6, but we need to conclude with x is equal to something. We need x is equal to blank. We have u is equal to that, so we need to go one step further. So this is when we bring back the rule that we established at the beginning. That rule will help us convert from u's to x's. So now, the rule says that u is equal to 2x plus 4. So what did we find u to be? U was 6. So now it's 6 is equal to 2x plus 4. And by solving for x, you subtract 4 on both sides and you divide by 2. You would get that x is 1. And that would be your final answer. Just x is 1. So does anyone have any questions about that one so far?
You just kind of like, it looks like you just kind of like threw out like 2x plus 4. Like, see, it's like on both sides. So you just like throw one out?
Throw one out? One of what exactly?
Like, there's 2x plus 4 squared and then there's another 2x plus 4 squared. So you just only use one of them?
Well, the reason, you mean at the very beginning up here?
Yeah.
So what's happening here, one of them's squared and one of them's not squared. So what we're doing is we're saying that this part right here, that part right there is u. So just 2x plus 4. But then what happens when there's a 2x plus 4 squared? Well, we said that 2x plus 4 on its own is u. And then, hey, look, there's just a square that happens to be there right here.
Okay.
So that's it's kind of a nice extension. We're utilizing the pattern for the substitution. So that's where it's coming from. Any other questions? Okay, well, problem 4 definitely looks different than the previous 3 problems. There's no discernible pattern here that we can utilize. However, this means that we need to work towards that form. So you might hopefully recall from the previous section that we dealt with radical equations. So in that section, what we did was, well, we isolated the radical expression and then we got rid of it. Well, problem 4 here is no exception. So by having the 4th root, I'm just going to rewrite it. So here, the radical expression is already simplified or isolated. So what did we do in the previous section? We got rid of the radical by raising both sides to a certain power. So how do you get rid of a 4th root? Take a 4th power. So we're getting rid of the radical first. In other words, radicals are not very nice to deal with. So we're getting rid of the radical. So a 4th root will cancel with a 4th power. And what we are left with, over here, the radical is just gone. Nothing else changes. And now we have x to the fourth power. So now that we have this, well, in the previous three problems, we had a form that was very helpful to us, or we've had forms that were very helpful to us. In the previous three problems, every expression was equal to zero. So equal to zero, even problem 3 was equal to 0. Here we are not equal to 0. So we haven't seen this yet. However, we can go ahead and make this equal to 0. So that's actually a really helpful thing, to set a polynomial equal to 0, which means we need to move some terms around. So I'm going to move the terms over this way. So I'm moving them to the other side, just so I can set this equal to 0, like I am now. So we have x to the fourth. 8x squared is now moved over, so now it's minus 8x squared. And then 12, we move, or negative 12, we move that over, so now it's plus 12. And I want this in descending order as well, yes?
Why wouldn't you just move x to the fourth?
That's a good question. Why wouldn't I move x to the fourth over? It's because you don't want your largest term to be negative. That's why. That's a good question. Why make more work on yourself? You don't want the highest degree term to be negative. So that would be x to the fourth, because 4 is the highest power. It makes factoring easier in the long run. So that's a good question. All right, cool. So now we have it in a very nice form. It's standard form, as we generally call it. But you might notice something. So we can't factor this. It's not a quadratic because the powers are not 2 and 1. They're 4 and 2. But in example 1, we did have something like this, where the powers were 4 and 2, and we somehow were able to deal with it. So what did we do in that problem? We used U substitution. So as I mentioned, generally, if you put this in standard form, generally the middle term gives you an idea of what U is. That would be x squared. And it turns out that this extends nicely. So this is more so if you want to know this, I'll write it. The x to the fourth that was in the front, x to the fourth is just x squared squared. But what did we say x squared was? We said that's u. So that's why we are going to replace x to the fourth with u squared. Again, these problems normally end up working out to where this will happen every time. But if you want to be convinced of why that's the case, then here's a derivation. But in any case, the U substitution allows us to rewrite this problem as 0 is equal to u squared minus 8u plus 12. Notice how all the numbers carry over. The numbers need to carry over, if there are any. And from here, we can factor. I think I see 6 and 2. They multiply together to give us positive 12. They add together to give us negative 8. And so we get two answers, positive 6 and positive 2 for U's. So we have U values, but u values are not good enough. We want x values, which means that rule that we established, the u is equal to x squared, we're going to resurface that rule. So I'm just going to restate it. So this was the rule that we established. And from that, we're going to have two different cases. Because we found two values for u, so naturally, if u here is 6, as we found, then now we have 6 is equal to x squared. And another u that we found was 2. So now 2 is equal to x squared. So now we need to go ahead and solve for x in both cases. So how do you get x by itself when there's a square attached to it? Take a square root, which means you'd have to do a plus or minus. Same over for this one. And if you try to put this in the calculator, either one, it's going to be a really messy decimal. And my math lab generally wants exact answers. So your answers, you would have to just write them out. But there's an issue here. Because we started off the problem with an even root. So whenever you start off the problem with an even root, you might get extra answers that end up not working at the very end of the problem. So to convince you of which one or ones are bad, so we found 4 solutions here. 2 of these, well, the extra solutions, they're fairly simple to figure out without having to do much work. So notice that if x is equal to negative square root of 6, then what we would have is that the 4th root of 8x squared minus 12 would equal that. There's an inherent problem here, though. The 4th root cannot output a negative. We talked about this before. A square root cannot output a negative. A 4th root cannot output a negative. This cannot happen. So that means the negative square root of 6 would be rejected. We toss it, because this cannot happen. Same with the negative square root of 2. That was another one we found. This cannot happen either, because a 4th root cannot output a negative number. Simple as that. So that means we would toss the negative square root of 2. And now we only have 2 answers, because we tossed the extra solutions. This one's a little bit tricky for that reason, but primarily this is the process for handling it. So it's definitely good to utilize that idea that square roots, 4th roots, even roots in general cannot output negative numbers. We'll actually see another situation of this later on in the section. Does anyone have any questions before I proceed? If not, go ahead and scroll down a little bit for those of you who might still be writing. So we'll look at problem 5. And you might think, well, what in the world is the u substitution for this problem? And my answer to that is I don't think you have to use U substitution here. In fact, it's easier for this problem because we have two terms. We have two terms, and they both have something in common. What they have in common is an x. They both have an x in common. We haven't seen this in the previous problem, so that's why we want to utilize this as such. So they both have an x in common, so I'm going to factor out an x. So 1 minus 4 square root of x is equal to 0. All I didn't do any substitution. I saw that both terms had an x in common, so I factored out the x. If you factor out an x from x, you get 1. If you take the x out of negative 4x square root of x, just get the square root of x. You can verify this by quickly distributing back in, and you get right back to where you started. The reason why factoring is so nice is because now we have a bunch of individual components that we can break up. So we have smaller components. So x, you can now set that equal to 0. And also 1 minus 4 square root of x is equal to 0. So conveniently, one of them's already solved for. So we just have one more. So from here, we can, for the second one, we can go ahead and solve for x. And we can subtract 1 on both sides, or what I'm going to do is add 4 square root of x on both sides. I'm trying to isolate the radical. So that would be 1 is equal to 4 square root of x. You could have also subtracted 1 on both sides, and then the negative signs would cancel. In any case, you would reach this point, or you should reach this point right here. From here, we can divide both sides by 4 to get the square root by itself. So all I did was just divide both sides by 4 to get that 4 out of the way. And now I just have to get rid of the square root by squaring both sides. So now we have x by itself, and 1 over 4 squared, just 1 over 16. So we get 2 answers. Does anyone have any questions up to this point? So that one was a little bit different than the other problems. I wanted to show everybody that. So for the next problem, problem 6, there is a pattern. There is a discernible pattern. And you might notice the repetition of the x squared plus 24x. That is definitely not a coincidence. That is an explicit pattern that we want to utilize. So U substitution is the way to go for explicit patterns. The problem is, what is U exactly? Because if you make U just equal to x squared plus 24x, then how do you take care of the square root part? What do you do with the square root? Well, you have to take care of the square root as well, because and that in that form, you would get u plus square root of u is equal to 30. And you will end up having to do a lot more work. You'd have to FOIL somewhere, and it'll end up being a lot worse off than what I'm about to write. So you need to include the square root, because this is one variable expression. And then what happens if you square both sides? So if you were to square that, well, the square root would cancel out, which is fine, because look what remains right here. That would be u squared. So it works out perfectly. So now we can go ahead and apply the u substitution, which would be u squared plus really u is equal to 30. Or in other words, u squared plus u minus 30 is equal to 0. So we can get it into standard form right quick. Once we get it into standard form, we can go ahead and factor. It's like 6 and minus 5. So we get that u is equal to -6 and +5. But we are not done yet. U's are not good enough. We need to switch to x's. We need to go ahead and switch to x values. What we need to do is bring back the rule that we established. The rule helps us convert from u's back to x's. And so we found two u values. First one we found was -6. So actually, I'll just do these one at a time. So the first u value we found was -6. So now we set -6 equal to this entire square root. Just like that. So that's the first u value we found. However, there should be something alarming that you should notice straight away. Square root cannot output a negative. This cannot happen. The square root cannot output a negative number. So this cannot happen, which means that we get no solutions from this. So this is why it's important that you are able to identify this, that square roots, fourth roots, sixth roots, they do not output negative signs. And so you can stop there. Because if you work this out, you'll find two solutions that you'll end up rejecting later. If you identify this now, then you don't have to check your answers because you found the extra solutions a lot more quickly. Now the other u value we found is positive, so this should be okay. Go ahead and look at the second u value, which was 5. And so now we have 5 is equal to a square root, which means we can square both sides to get rid of these square roots. So that's 25 is equal to now x squared plus 24x. Or in other words, 0 is equal to x squared plus 24x minus 25. Which we can go ahead and factor. So plus 25 and x minus 1. Then we just get that x is equal to negative 25 and positive 1. And that would be your final two answers for this problem. Oops. Does anyone have any questions about this one before we move on? Okay, we'll move on to problem 7. And problem 7, it's another one of those, it's close to quadratic, but it's not quite a quadratic. So pretty much what we would like is for this to be 6x squared minus 9x plus 2, something like that. But we can't just assert that just offhand. That's why we have to use u substitution. So with u substitution, again, the middle variable expression tends to give us an idea. And that's really helpful because if you square x to the 1/4, you get x to the 1/2. But once you have that established, we can now go ahead and start making the appropriate substitution. So now it's 6u squared, because x to the 1/4 squared is 1/2, minus 9u plus 2 is equal to 0. So as long as you make the correct rule, then it should work in order. So you should have variable squared, variable, and then number. And then from here, we can go ahead and factor. Now, this is the first one where we have to factor using the AC method. So if you try using the AC method, it would be, well, 6 times 2, which is 12. And you'd have to find two numbers that multiply to give you 12 and add together to give you -9. But if you go through all the combinations, you will not find one. In other words, this is not factorable. The AC method will not work here. So you have to use the quadratic formula. So with the quadratic formula, it now tells us that u, not x, but u is equal to, and just as a reminder, well, A is 6, B is -9, C is 2. And from here, we can use minus -9 plus minus the square root. -9 squared minus 4 times 6 times 2. All of this divided by 2 times 6. So now we have 9 plus or minus the square root of, imagine that's 33. Four 48, 81, 48, yeah. So we get this for you. And the square root of 33 does not simplify. So we would have to leave it in this form for u. But u's are not good enough. Oh, sorry, yes.
Could you simplify the 9 over 12?
You cannot. You'd have to simplify 12 with the square root of 33 as well. So, yeah, so that's a good question. Can you simplify the 9 and the 12? You can't because this the square root of 33 is in the way. But u's are not good enough, and this is the most simplified we can leave u right now. But we need to go back to x's. And so the rule that we had was u is equal to x to the 1/4. This was the rule all the way from the beginning. So what this tells us is that, well, we found u to be 9 plus or minus the square root of 33 over 12. That is now equal to x to the 1/4. And now to get x by itself, well, to get x by itself when it's x to the 1/4, x to the 1/4 is the same thing as the 4th root of x. So to get rid of the 4th root, you have to take a 4th power, which means the final answer will be that whole value of u raised to the 4th power. And I promise this is the answer that you put into my math lab, right there. So that is the answer you put into my math lab with the minus as well. With the minus as well. So there is a plus or minus symbol in my math lab that you can utilize. But that is the answer you put in. It's not a very pretty answer, but that is what you put in. Does anyone have any questions about this one? If not, let's look at problem 8. So problem 8, this one does have a quadratic feel to it. Pretty much if we could get rid of those negative exponents, then it would be a very nice quadratic. But we can't just establish that without using a u substitution, without establishing a rule of some sort to do that. So what we have to do, so the rule here, generally the middle variable gives us an idea, that would be x to the -1. And by extension, that would make u squared equal x to the -2 over here. But by establishing this rule, now we can convert this as u squared minus 5u plus 6 is equal to 0. So now we have converted this equation into a quadratic equation, which means we can now factor. So I see 2 and 3. which tells us that u would be equal to positive 2 and positive 3. So we convert to a quadratic using the substitution method, and that allows us to factor and figure out the values of u. Negative 2 times negative 3 is positive 6, and their sum is negative 5. But we're not done yet, because we need to bring our rule back, which helps us convert from u's to x's. So now we have u is equal to x to the negative 1. We found two values of u. So now 2 is equal to x to the negative 1, and 3 is equal to x to the negative 1. Now the question is, how do you get an x by itself if there's a negative 1 on it? So in order to cancel out a negative 1 exponent, really you can think about it as you flip the other side. So in other words, x, now without the negative 1 exponent, will be moved to the 2. So notice the 2 now has the negative 1 exponent. So in other words, you raise both sides to the negative 1 power. So negative 1 power raised to a negative 1 power. That pretty much means you flip and then you flip again, which means they cancel each other out. So this makes sense. So that's just 1/2. And then over here, same idea. X now does not have a negative 1 next to it, and this is 3 to the negative 1, which means you just flip the 3. So you get two answers. Does anyone have any questions up to this point? So if not, that is everything for the substitution method section. And again, that homework will be due tomorrow night. If there's no questions about that, let's move on to solving equations by factoring. So this previous section we had on the u substitution, I think that's the hardest section going into the midterm. And the section coming up is probably the easiest one going into the midterm, because this section is a glorified factor by grouping section, which we do for the AC method. So if you're comfortable with that method, then this section might not be that much of an extension to what you already know. So for example 1, and you will notice that some of these problems work out fairly quickly. So if anything, for example 1, so factor out the greatest common factor from the following polynomials. So what we're doing is we're noticing this pattern occurring in both terms, just like if we were doing the AC method. Since they both have the same value, that's what we can factor out. So they both have an x plus 9, so we factor out an x plus 9. So what does that look like after we factor out the x plus 9s? What's left over? So what's left over is 5 plus 4a. I see a 5 over here, and I see a plus 4a over here. And that's it. We're already done. That's it for this problem. That's all they asked us to do. So this would be your answer. Nothing more. It doesn't want you to solve anything. It just wants you to factor. Part 2 over here, same idea. Both both of these terms have a 2x to the 8th power plus 9. So that's what we can go ahead and factor out. So what happens when we factor those out? What are we left with? Looks like a 3x plus 4. And that's it. That's all we do for this problem. So I think so far, pretty straightforward. Yes?
Is this like the next homework we have?
Mhm.
Okay.
This one should be fairly quick to knock out, I think. Yes, this pertains to your next homework and the last homework before the midterm. So after this section, that's everything that pertains to next week's midterm. So let's move on to example 2 here. We're going to factor this polynomial. Now, to factor a polynomial with 4 terms, we will use grouping. Anytime you see a polynomial with 4 terms, we use grouping. This is the same thing with the AC method. We used factoring with the AC method because once you applied the 2 numbers that you found, and you have 4 terms, and you would use grouping. So when I say grouping, that you use it when you have 1, 2, 3, 4 terms. All right, so we have 4 terms here. We would use grouping. What are we grouping? We're grouping the first 2 terms and the next 2 terms. So that's what we are grouping. And when I say or refer to grouping, so for each group, what do those 2 terms have in common? That's what we're looking for. So for the very first group, what do those 2 terms have in common? All I see is an x. They both have an x in common. They both have an x in common, and I'm factoring out an x. So 2x squared, I factored out an x, I'm just left with 2x. Plus 3xy, I factored out the x, so now it's just plus 3y. There's no more x, we factored it out. All right, the next 2 terms. 8x plus 12y. What do they both have in common? Not an x, not a y. They both have a 4 in common. Because 4 goes into 8 and 4 goes into 12. So I can factor out a 4. When I do that, well, 8x, I just factored out a 4. This is going to be left with a 2x. Because this is really division. This makes sense because if you were to distribute everything back in, you would multiply. So to take out would be to divide. And then 12y, we just factored out 4. Well, 12 divided by 4 is 3. And the y stays there because we didn't factor out a y. But notice exactly what we wanted to happen. Notice what repeats. This is necessary for grouping. You have to have the repeating part, which is why you have to factor in this way. Because now it just refers to a problem from the previous example. So what's the repeating part? It's 2x plus 3y. And then what's left over? X plus 4. And that's it. So just taking this one step further. And that would be your answer right there. So all it wants is factoring. So we'll go ahead and move on to example 3. So for all of these, now we're solving, so it's no longer factoring, but we're taking the steps one step further, and we will be concluding with x is equal to something or some things. So for part 1 here, well, if anything, we want everything on the same side of the equal sign. We want everything equal to 0. So we're going to move the 2x squared over. So now we have 9x to the third minus 2x squared is equal to 0. And this is helpful for factorization purposes, or factoring. Now we do not have 4 terms. We only have 2, which means we don't use grouping. We don't have to. So instead, we see that both terms have something in common. They both seem to have 2 x's in common, an x squared, that is. So we can factor out an x squared from both of these terms. Now, 9x to the third, we factor out x squared. So that's just 9x. Negative 2x squared, we factor out the x squared. We're left with minus 2. So we factored out an x squared. We didn't use grouping because we didn't have 4 terms. So instead, we factored out what these 2 terms had in common. And why factoring is nice is because now we just broke up a larger quantity into 2 smaller components. So now we have x squared is equal to 0. And we have that 9x minus 2 is equal to 0. So that's why factoring is nice. The bigger expression becomes 2 components, which we can then break up. For this first one, we just get that x is technically plus or minus the square root of 0, but that is just 0. Square root of 0 is 0, plus or minus is still 0. And that's how you get x by itself. And then the next one, 9x is equal to 2. Or in other words, x is 2 divided by 9. So we get 2 answers. So hopefully, so far, so good. Okay, so part 2 here, at least part 2, this one's already in the correct form, or it's in standard form, so we don't have to move things around. I see 4 terms, so we're going to use grouping. Group those 2 together, group these 2 together. For the first 2, the x cubed minus 4x squared, I see that they both have an x squared in common. They both have 2 x's in common. So if anything, I'm going to factor out an x squared. And what's left over? X cubed, which has 3 x's. We just took out 2 of those x's, so we're left with 1. And then minus 4. Because we took out x squared from 4x squared. Now the next part, I'm going to write this in red because this technically isn't the right way to do it. For the next part, this one right here, you might see that they both have a 16 in common. So if you factor out a plus 16, then what you would be left with is negative x plus, well, 64, you just factored out 16. 64 divided by 16 is 4. So you would get this. But there's a problem here. The problem is these two factors do not match. That's not good. They're really close, though. They are very close. So the solution to this is we need to factor out not 16, but negative 16. So by factoring out negative 16, that will not only give us the x and the 4, but it will flip the signs. So if we take negative 16 out of negative 16x, if we take negative 16 out of negative 16x, we're just left with positive x. And then 64 divided by negative 16 would be negative 4. And now we have our match. And so with this match, we can go ahead and factor out this. So there's this common x minus 4. What are we left with after we factor that out? X squared minus 16. And then from here, it's just a matter, well, we have a factored form is equal to 0, which means that we can break this up. So the reason why a factored form is so nice is we could take a larger expression and break it up via the components, as we did here. The first one, that one's a little bit easier to determine. That one's just x is equal to 4. And the second one over here, we can go ahead and move 16 to the other side and take the square root to get x by itself. So we get the same answer twice. We get positive 4 2 times. So all you'd have to put is x is equal to 4 and negative 4. Okay. Does anyone have any questions about the first two? Well, number 3 here might be a little cut off, so let me rewrite it. So there are not 4 terms, so we don't have to use grouping. So again, there's not 4 terms, so we don't have to use grouping. However, what I do see is that all of these terms have something in common. They all seem to have an x in common. So I'm going to factor out an x. So what I'm doing, I'm I'm factoring out an x, which means I'm taking an x away from every term. That's why x to the third becomes x squared. Negative 16x squared becomes negative 16x. Plus 60x becomes plus 60. And we have a factored form equal to 0. So ideally, that means we can split this up. So now x is equal to 0, and x squared minus 16x plus 60 is equal to 0. Now, one of them is already solved for us. And the other one we have to factor. So the second one we factor seems to be x minus 6, x minus 10. Those multiply together to give us positive 60, add together to give us negative 16. And from here, we get that x is positive 6 and positive 10. So we get 3 answers. So finally, part 4, and I'll go ahead and rewrite it. So for this equation here, we want to go ahead and set it equal to 0. So put it in standard form. That'll help with factoring. I'm going to move these two over here so I can keep the largest degree term, the largest exponent term positive. So now this would be 2x to the third, now minus x squared, minus 18x plus 9 is equal to 0. So that's the first step. And I count 4 terms, so that means I will use grouping. So grouping, I will put these two together. I will put these two together. For the first two, they seem to have x squared in common. And so taking out 2 x's from 2x squared, that'll just leave us with 2x minus 1. Is negative 2x, we took out x squared, we're left with negative 1. And then for the next one that I have underlined in blue here, I'm going to take out a negative 9. Negative 9, because that'll not only take out a factor of 9, but it will flip all the signs. So negative 18 divided by negative 9 is positive 2 with an x. And then we get minus 1 for the next one. And now we get our pattern. So 2x minus 1 for the pattern, and then what's left over seems to be x squared minus 9 from this and this. And now we have a factor, or factorization equal to 0, which means each individual part can be set equal to 0. First one is fairly straightforward to solve for. You just add 1 on both sides and divide by 2. And then for the next one, you add 9 on both sides. Go ahead and take the square root. And plus or minus the square root of 9. The square root of 9 is just 3. So we get 3 answers here. Does anyone have any questions about anything up to here? So that's pretty much all the material I have that goes up to the midterm. So since I got everything done that I wanted to, I can make the next class period a homework review session, which means I will push the substitution homework to Wednesday, so Wednesday night. So during class time, it's optional. Wednesday is optional. If you have questions about any of the homeworks, I will be here. I will be in this exact same spot. You can come to class if you want. I'll be here, but it'll just be a review session. I won't be lecturing anything. If you want me to do homework problems, I will. So that's what it'll be. You're all caught up and feel fine with this material, you could sleep in. I don't care. So other than that, I'm gonna send out an email, and not too much time after this class, explaining how to sign up for the midterm remotely. If you're taking it in person, you don't have to do anything right now. If you want to take it remotely, I will give you the step-by-step instructions on how to do so. I'll be sending that out in a few hours. Other than that, that's really all I have. If you have any questions, I'll stick around. Other than that, yeah, that's it. Have a good day.
I have one question. How many questions is the midterm?
The midterm, when I glanced at it, I believe I saw 17 questions. You have 70 minutes. So Hannah, to answer your question, yes, if you come in person on Wednesday, you take the midterm on Wednesday. So that's correct. And Caitlin, yes, you do have to use the TI. I'll show you the one second. So you have to have this calculator, the TI-30X double. It's the one on the syllabus. So you can only use this one. So to answer your question, you have to use this calculator.
You gonna need practice for it, like I'll get for the test.
Yeah, there's a practice test up. Yeah, you should see it in there by now. Yep.
Sweet.